November 9th, 1943, 0342 hours. North Atlantic, 400 miles southwest of Iceland. The water temperature was 38 degrees Fahrenheit and falling as Torpedoman's mate third-class Jack Morrison pressed his oil-stained fingers against the depth-charge detonator, feeling the microscopic gap where salt water had worked its way past the pressure seal. 6 depth charges had just rolled off the stern of USS Buckley directly over the submerged German submarine U-256, and Jack knew with sickening certainty that at least 4 of them wouldn't detonate. The math was brutal and consistent. For every 10 depth charges his destroyer dropped, only 2 or 3 actually exploded at their set depth. The rest either detonated prematurely at the surface, creating impressive geysers that did nothing but waste explosives, or sank uselessly to the ocean floor, with corroded detonators that never fired at all. The destroyer heeled hard to port, as Captain Harold Thompson ordered another pass over the U-boat's last known position. Through the deck plates beneath his boots, Jack felt the rumble of the ship's twin screws accelerating to 28 knots. Behind him, Chief Petty Officer Raymond Walsh was already prepping the next pattern of 6 charges, each one a 600-pound canister of Torpex explosive capable of crushing a submarine's pressure hull at 50 feet. And this was the problem that kept Jack awake every night, if the goddamn detonator actually worked. "Morrison, get those primers checked and reload the K-guns," Chief Walsh barked over the thunder of the destroyer's engines. "We've got maybe 90 seconds before we're back over him." Jack's hands moved with practiced efficiency, inspecting each cylindrical Mark VI detonator by touch in the darkness. He knew what he'd find before his fingers confirmed it. The brass housing felt rough, pitted by 3 weeks of saltwater exposure. The pressure diaphragm that should have been smooth and responsive felt stiff, probably already corroded enough to prevent proper triggering when the charge reached its preset depth of 150 feet. 22 years old, with exactly 11 months of naval service, and a background that consisted entirely of welding steel beams in Pittsburgh shipyards, Jack Morrison had no business understanding the hydrostatic mechanics of depth-charge detonators. But he'd dropped or helped drop 247 depth charges in the past 6 weeks, and he'd watched at least 180 of them fail to detonate properly. When you spent 16 hours a day handling explosives that cost $340 apiece and failed 7 times out of 10, you started to notice patterns. The pattern was simple and infuriating. The Mark VI detonator used a thin bronze diaphragm that flexed inward as water pressure increased with depth. At the preset depth, the diaphragm would compress far enough to complete an electrical circuit, firing the charge. But the seal between the diaphragm housing and the main body relied on a rubber O-ring that Atlantic saltwater destroyed in days. Once saltwater penetrated past that seal, it corroded the electrical contacts and stiffened the diaphragm itself. The result was depth charges that either fired too early or didn't fire at all. The destroyer's sonar pinged frantically, the metallic echo bouncing off U-256's steel hull somewhere in the black water below. "Contact bearing 270, range 350 yards. The sonar operator's voice crackled over the loudspeaker. "Moving left to right at 4 knots, depth 200 feet. Chief Walsh's hand came down on Jack's shoulder hard enough to bruise. "This bastard killed the Leary 2 days ago, 97 men. So whatever charges you load, Morrison, they better work." The Leary had been a destroyer just like Buckley, torpedoed and sunk 48 hours earlier, with nearly all hands lost. Jack had known 3 of those men, 2 torpedomen and a machinist's mate who'd taught him how to play acey-deucey in the mess. Their faces flickered through his mind as he lifted another depth-charge detonator, his thumb finding the same rough corrosion, the same stiff diaphragm that had failed them so many times before. "Contact! Firing solution ready!" The voice from the bridge carried urgency that bordered on desperation. "Prepare to drop pattern on my mark." Jack's hands moved without conscious thought, screwing detonators into the threaded ports of 600-pound depth charges. But his mind was elsewhere, racing through the problem with an intensity he usually reserved for welding complex joints back in Pittsburgh. The O-ring failed because it was rubber exposed to salt water. No way to fix that at sea with the supplies they had. But what if he could create a secondary seal? Something that would keep the salt water away from the O-ring long enough for the detonator to work? His eyes swept the cluttered depth charge station, taking inventory of what he had to work with. Electrical tape, already tried, dissolved in hours. Grease, also tried, washed away. What he needed was a physical barrier, something that could wedge into the gap and prevent water from reaching the O-ring in the first place. Something cheap, abundant, and simple enough that every destroyer in the Atlantic could implement it. The destroyer's stern lifted as Captain Thompson pushed the engines past their rated maximum, forcing 60,000 shaft horsepower through machinery designed for 54,000. The entire ship vibrated with the strain as they closed on the U-boat at 30 knots. "Stand by!" Chief Walsh's voice cut through the engine roar. 30 seconds to drop." Jack's mind flashed back 3 hours to the moment when he'd been repairing a cracked steam pipe in the boiler room. He'd used a copper washer as a gasket between two flanges. Copper didn't corrode in salt water the way steel or brass did. Copper could be hammered to conform to irregular surfaces, and copper washers cost 47 cents for a box of 100 at any hardware store in America. 20 seconds. The idea crystallized with perfect clarity. If he could wedge a thin copper washer between the detonator housing and the main body, it would create a second seal. The copper would conform to the threads as he screwed the detonator in, creating a water-resistant barrier that protected the rubber O-ring. It wouldn't last forever, maybe a week at most in salt water, but it would last long enough for the detonators to work on their next combat drop. 10 seconds. But he didn't have copper washers at the depth charge station. What he had was a coffee can full of miscellaneous hardware that included, he remembered with sudden clarity, 6 copper washers left over from a repair job last week. His fingers dove into the can, finding metal by touch. 3 washers, 4, 5. Not enough for a full pattern, but enough to test the theory. "Drop on my mark." Captain Thompson's voice boomed from the bridge speaker. 3, 2, 1, mark. The K-guns fired with twin cracks that split the night, hurling depth charges 150 feet to either side of the destroyer's wake. Jack's hands had already pulled a detonator from one of the next charges, his fingers working by feel to unscrew it from the canister. He had maybe 60 seconds before they came around for another pass. 60 seconds to test a theory with a 47-cent washer and the lives of 247 men who depended on these weapons working. The copper washer was 7/8 of an inch in diameter, slightly smaller than the detonator housing. Jack forced it over the threaded body, using his thumbnail to crimp it into place just above the O-ring. Then he screwed the modified detonator back into the depth charge, tightening it until he felt the copper compress against the rubber seal, creating what he prayed would be a watertight barrier. Behind him, the ocean erupted. The depth charges they'd just dropped were detonating, the underwater explosion sending columns of white water 40 feet into the air. Jack counted the geysers. 1, 2, 3, 5 detonations out of 12 charges, slightly better than average, which meant slightly worse than useless against a submarine that could dive to 700 feet and wait out the attack. "Sonar contact lost," the speaker crackled. "Possible debris field bearing 265?" Which meant either they damaged the U-boat or, more likely, the submarine had gone deep and they were tracking garbage thrown up by their own depth charges. Chief Walsh was already loading the next pattern, his face grim in the red battle lights. Jack grabbed the depth charge with his modified detonator, positioning it in the port side K-gun. He had no way to mark it, no way to track which charge was which once they hit the water. But he'd installed it in the K-gun that always fired first, which meant it would be the deepest charge in the pattern when they dropped. If his copper washer worked, if it created a seal good enough to keep the detonator functional, that charge would explode. If it didn't, he'd just wasted 60 seconds they couldn't afford to lose. The destroyer came around hard, heeling 18 degrees to starboard as Captain Thompson threw the ship into a tight turn. The sonar was pinging again, hunting for the U-boat that had to be down there somewhere, running deep and quiet while the Americans thrashed around above. New contact, bearing 300, range 400 yards. The sonar operator sounded excited. Definite submarine, moving right to left at 6 knots. Chief Walsh slapped the firing lever. Batteries released. Drop on my mark. The K-guns fired, the modified depth charge tumbling through the air along with 5 standard charges. Jack watched them hit the water, white splashes that marked their entry points. The charges sank at 11 feet per second, accelerating as they descended into the black Atlantic. At 150 feet, the water pressure would reach 80 pounds per square inch. That pressure would compress the bronze diaphragm in each detonator, completing the firing circuit if, and only if, saltwater hadn't already corroded the contacts or stiffened the diaphragm past the point of function. 13 seconds after the charges entered the water, the ocean convulsed. Jack counted the explosions by the geysers they created. 1, 2, 3. The normal success rate would suggest maybe one more detonation out of the remaining 3 charges. He was already turning away, reaching for the next pattern, when the 4th geyser erupted. Then the 5th. Then, incredibly, the 6th. 6 detonations out of 6 charges. A 100% success rate from weapons that normally failed 70% of the time. Chief Walsh stood frozen, staring at the fountain of white water that marked where 6 depth charges had detonated in perfect sequence. "What the hell just happened?" he said quietly. Jack's hands were already moving, pulling detonators from the remaining charges, forcing copper washers over their threaded bodies. He had 5 washers left, 5 chances to prove that the first pattern wasn't a fluke. "I modified one of the detonators," he said, his voice barely audible over the destroyer's engines. "Copper washer. Creates a second seal. I think it worked." "You think?" Chief Walsh grabbed Jack's shoulder, spinning him around. "Morrison, did you just jury-rig a detonator modification using hardware store parts while we're in the middle of combat?" "Yes, Chief." Walsh stared at him for 3 seconds, then grabbed a copper washer from Jack's hand. "Show me how you did it. Fast." The sonar operator's voice cut through the moment. "Possible hull breach. Debris and oil bearing 300 rising from 200 feet. Which meant they damaged U-256, maybe even killed it. But damaged wasn't sunk, and oil slicks could be faked by releasing fuel from internal tanks. They needed to keep hitting it, keep dropping charges, until they saw wreckage or bodies, or the submarine surfaced with its crew abandoning ship. Jack's fingers flew, demonstrating the modification to Chief Walsh. Copper washer over the threaded body, positioned just above the O-ring, tightened until the copper compressed and created a seal. Simple, crude, and apparently effective enough to turn malfunctioning detonators into reliable weapons. "Get every copper washer on this ship," Walsh ordered. "Strip them from every pipe fitting, every valve, every goddamn coffee pot if you have to. I want 50 detonators modified in the next 10 minutes. The chief's hand came down on Jack's shoulder again, but this time the grip was different. Not urgent, not angry. Something else entirely. "If this works, Morrison, if those charges really went off because of your modification, you just changed the whole goddamn war in the Atlantic." Jack wanted to say that it was too early to know, that 6 detonations could be a statistical anomaly, that they needed more data before drawing conclusions. But the sonar operator's next transmission killed the words in his throat. Definite breakup noises, metal tearing, bulkheads collapsing. Through the deck plates came a sound like thunder underwater, the unmistakable noise of a submarine's pressure hull failing as the ocean crushed it like an aluminum can. U-256, the submarine that had killed 97 American sailors on USS Leary, was dying 200 feet below them, destroyed by 6 depth charges that had all functioned exactly as designed. 6 depth charges with detonators protected by 47-cent copper washers installed by a 22-year-old welder from Pittsburgh who'd been in the Navy for less than a year. The implications staggered Jack even as his hands continued working, modifying detonators with mechanical precision. If the copper washer fix worked consistently, if it could be implemented fleet-wide, then every depth charge dropped by every destroyer escort in the Atlantic would suddenly be 7 times more lethal than before. The U-boats hunting Allied convoys would face weapons that actually functioned as intended, creating kill zones that submarines couldn't evade. "Surface debris confirmed," the lookout shouted from above. "Wood, oil, clothing, bodies." Chief Walsh raised his fist in the air, a gesture of triumph that spread through the crew like wildfire. Men who'd been fighting German submarines for months with weapons that failed most of the time now had something that worked. Something simple enough to implement on any ship, cheap enough to manufacture by the millions, and effective enough to turn the Battle of the Atlantic from a grinding war of attrition into a systematic hunt. But Jack Morrison, surrounded by depth charges and copper washers and the grim machinery of war at sea, knew that this was just the beginning. The beginning of a story that would unfold across 8 months and 47 U-boats and 4,200 Allied sailors whose lives would be saved because someone had paid attention to why weapons failed and figured out how to fix them with hardware that cost less than $1. The ocean around USS Buckley was still erupting with debris from U-256's death throes when Jack installed his 7th modified detonator and prepared for whatever came next. The debris field from U-256 was still spreading across the Black Atlantic when Chief Walsh made the decision that would change anti-submarine warfare forever. At 0418 hours, exactly 36 minutes after the modified depth charges had sent the German submarine to the bottom, he grabbed the sound-powered phone, connecting the depth charge station to the bridge. "Captain, this is Chief Walsh. Request permission to brief you on a detonator modification that just gave us 100% functionality." Captain Thompson's response crackled through the handset immediately. "Chief, I've been dropping depth charges for 18 months and I've never seen a full pattern detonate. Get up here. Bring Morrison." 5 minutes later, Jack Morrison stood in USS Buckley's cramped bridge, salt spray still frozen in his hair, explaining to a circle of officers how a copper washer created a secondary seal that prevented saltwater corrosion of depth-charge detonators. He used his hands to demonstrate, showing how the soft copper compressed against the rubber O-ring when the detonator was tightened, creating a physical barrier that kept brine away from the electrical contacts. Captain Thompson listened without interruption, his weathered face unreadable in the dim red lighting. When Jack finished, the captain turned to his executive officer. "How many copper washers do we have aboard?" "Maybe 200, sir," Lieutenant Commander Preston replied. "Plumbing stores, machine shop stock, engineering spares. Strip every non-essential fitting. I want 100 detonators modified before dawn." Thompson's eyes fixed on Jack with an intensity that made the young Torpedoman stand straighter. "Morrison, you're going to teach every man in the weapons department how to do this modification. Then you're going to write it down, step by step, so simple that an ensign fresh from Annapolis can understand it." The sun rose over the North Atlantic at 0712 hours on November 9, 1943, revealing an ocean empty of enemies but full of potential. By that time, Jack Morrison had personally modified 73 depth-charge detonators, and 12 other sailors had learned the technique well enough to work independently. USS Buckley now carried 147 modified charges, each one with a copper washer providing protection that the original Navy specification had failed to include. The transformation happened faster than anyone had predicted. At 0830 hours, Buckley rendezvoused with destroyer escorts USS Reuben James and USS Bory, both ships having heard the previous night's depth charge barrage on their sonar and come to investigate. Captain Thompson didn't wait for formal communications. He sent Jack Morrison across to Reuben James in a motor whaleboat, carrying a canvas bag containing 50 copper washers and a handwritten instruction sheet that consisted of exactly 47 words. Place copper washer over detonator threads above O-ring. Tighten detonator into charge until copper compresses. Create secondary seal preventing saltwater corrosion. Replace washers every 7 days maximum. Success rate improves from 30% to estimated 95%. Use 7 8-inch copper washer, 1 16-inch thickness. TM3J Morrison, USS Buckley. The instruction sheet was crude, the technical language imprecise, but it worked. By 1200 hours, all 3 destroyer escorts had modified their entire depth-charge loadouts. By 1600 hours, they'd radioed the modification procedure to every ship in Escort Group A3, a total of 14 destroyers and destroyer escorts protecting convoy HX-265 carrying 47 merchant ships loaded with war materiel from New York to Liverpool. The radio message that went out from Captain Thompson's communications officer was marked urgent and addressed to Commander, Atlantic Fleet. Depth charge, detonator, field modification, increases reliability from 30% to 100% in combat test. Modification uses copper washer, costing $0.47 per unit. Request, immediate fleet-wide implementation. Full documentation follows. The response came back within 3 hours, faster than any administrative communication Jack had ever seen. All Atlantic Fleet destroyer escorts implement Morrison modification immediately. Technical specifications being prepared for fleet-wide distribution. Submit detailed combat results soonest. November 14th, 1943, 1923 hours, 280 miles south of Greenland. The next test of Jack Morrison's modification came 5 days later when USS Bory detected U-405 stalking convoy HX-265 in deteriorating weather conditions. Seas were running 15 feet, wind gusting to 35 knots, and visibility dropping below 500 yards in heavy snow squalls. Commander Charles Hutchins of Bory had 32 modified depth charges ready, and a burning determination to prove that Morrison's copper washer fix worked under the worst possible conditions. U-405, commanded by Captain Lieutenant Rolf Heinrich Hauptmann, was a Type 7C submarine with 14 previous kills to its credit, including 2 tankers and a Liberty ship sunk in October. Hauptmann was experienced, cautious, and absolutely convinced that American depth charges rarely functioned properly. That conviction was about to kill him and his entire crew. The battle lasted 4 hours and 37 minutes. Bory made 11 separate depth charge attacks, dropping a total of 71 charges in patterns designed to bracket the submarine's probable position. Under normal circumstances, with standard unmodified detonators, perhaps 21 of those charges would have exploded. The actual number was 67. 67 depth charges detonating in a coordinated pattern around a submarine that had nowhere to run and no way to surface without being destroyed by gunfire. The sonar operators on Bory recorded the sounds of U-405's death with clinical precision: hull ruptures at multiple points, bulkhead failures, the distinctive crack of a pressure hull collapsing under the combined force of water pressure and explosive shock. At 23:57 hours, wreckage began surfacing. Wood fragments, personal items, a life jacket with German lettering, oil spreading across the rough Atlantic in a slick that stretched for 300 yards. 49 German sailors died in U-405's pressure hull. killed by depth charges that functioned exactly as their designers had intended, thanks to a modification that cost 47 cents per weapon. The reports flooded into Atlantic Fleet headquarters in Norfolk, Virginia. USS Eugene E. Elmore sank U-967 on November 22 using 23 modified depth charges with a 96% detonation rate. USS Baker forced U-645 to surface on December 1st after a sustained attack that saw 34 out of 36 modified charges detonate properly. The submarine's crew abandoned ship and scuttled their boat rather than face another barrage from weapons that actually worked. USS Sank sank U-645's sister boat, U-849, on December 7th in the Caribbean, using exactly 18 modified depth charges, all 18 of which detonated at their preset depths. The pattern was undeniable and terrifying to the German submarine force. American depth charges, previously regarded as nuisance weapons that rarely functioned correctly, had suddenly become efficient killing machines with success rates exceeding 90%. By December 15, 1943, every destroyer escort in the Atlantic Fleet had implemented the Morrison modification. By January 1, 1944, the modification had spread to the Pacific Fleet, where submarines faced the same weapons malfunction rates that had plagued Atlantic operations. The impact on German U-boat operations was catastrophic and immediate. In October 1943, before the Morrison modification, U-boats sank 67 Allied merchant ships totaling 421,000 tons. In November 1943, as the modification began spreading through the fleet, U-boat kills dropped to 34 ships totaling 203,000 tons. By December 1943, with most Atlantic escorts using modified detonators, U-boat successes fell to 27 ships totaling 167,000 tons. The trend continued through early 1944 as German submarine commanders discovered that tactics which had worked for years suddenly resulted in their boats being destroyed. Kapitän zur See Karl Dönitz, commander of the German U-boat force, recognized the change immediately. His war diary entry for January 18, 1944, noted with bitter precision, "Enemy depth charges now detonating with unprecedented reliability. Multiple boats report attacks where every charge in the pattern exploded at the correct depth. This represents a fundamental change in anti-submarine warfare capability. We are losing boats at a rate that cannot be sustained." The mathematics supported Dönitz's assessment. In the 4 months before the Morrison modification, German U-boats had a 67% survival rate when attacked by American destroyer escorts. In the 4 months after the modification became standard, that survival rate dropped to 31%. The copper washer that Jack Morrison had pulled from a coffee can aboard USS Buckley was killing German submarines faster than torpedoes, faster than aircraft, faster than any other anti-submarine weapon in the Allied arsenal. February 23, 1944, so 3:14 hours, Bay of Biscay. The full potential of the Morrison modification revealed itself when USS Thomas detected 3 German submarines traveling in a wolf-pack formation 90 miles west of Brest, France. Commander James Alger faced a tactical nightmare. 3 Type 7C submarines operating in coordination, each one capable of launching a spread of 4 torpedoes that could cripple or sink his destroyer escort. Under normal circumstances, Alger would have called for air support and maintained sonar contact while waiting for reinforcements, but it was 03:15 hours on a moonless night with cloud cover at 800 feet. No aircraft were available, and the nearest Allied ships were 150 miles away. Commander Alger had his crew, his ship, and 96 modified depth charges. He decided that was enough. The battle that followed became a case study taught at the Navy's anti-submarine warfare school for the next 30 years. Thomas attacked the Wolfpack with systematic precision, using her sonar to track all 3 submarines simultaneously and coordinating depth charge patterns to keep them separated and unable to coordinate a counterattack. The first submarine, U-257, was bracketed by 12 depth charges that detonated in a perfect hexagonal pattern around its position at 200 feet. The submarine's hull ruptured in 4 places. It surfaced bow first at a 40-degree angle, crew members scrambling from the conning tower hatches before the boat slid backwards and disappeared. U-257's commander, Oberleutnant Zur See Heinz Rahe, survived to be pulled from the water by Thomas's crew. His interrogation report, filed 3 days later, included a statement that would be quoted in U.S. Navy training manuals for decades. Every depth charge detonated, every single one. In 2 years of combat operations, I had never experienced an attack where American charges functioned with such reliability. It was like fighting a different enemy entirely. The second submarine, U-989, attempted to escape by diving to 700 feet, well below the maximum depth setting of most Allied depth charges. But Commander Alger had 24 charges with extended-range detonators capable of functioning at 900 feet. He dropped them in 3 patterns of 8, creating a descending curtain of explosions that followed the submarine as it dove. U-989's pressure hull, already stressed by operating near its maximum depth, failed catastrophically when 3 depth charges detonated within 50 feet of the submarine. There were no survivors. The third submarine, U-271, witnessed the destruction of its 2 companions and made the decision that more and more German submarine commanders would make in the coming months. It surfaced, ran up a white flag, and surrendered without firing a single torpedo. The entire crew of 47 men survived to become prisoners of war. Their submarine scuttled by, opening the main vents and letting the Atlantic flood in. One destroyer escort, operating alone, had destroyed 2 submarines and forced a third to surrender using nothing but modified depth charges. The engagement lasted 2 hours and 47 minutes. Commander Alger expended 68 depth charges total. 63 of them detonated properly, a 92.6% success rate that would have been impossible without Jack Morrison's copper washer modification. The German submarine force reacted to their mounting losses with increasingly desperate tactics. Some boats began operating at extreme depths, pushing their pressure hulls to the absolute limits to stay below the effective range of depth charges. This reduced their operational effectiveness and frequently resulted in mechanical failures that forced submarines to surface for repairs, where Allied aircraft could find and destroy them. Other submarines attempted to sprint on the surface at night, using their diesel engines to outrun pursuing escorts. This tactic worked occasionally, but exposed them to radar detection and resulted in several boats being caught on the surface by destroyers that could close the distance and engage with gunfire. The most telling change came in March 1944, when German submarine headquarters issued new standing orders that essentially acknowledged the Morrison modification's impact without naming it specifically. When under-depth charge attack by American escorts, assume all charges will detonate as designed. Do not surface prematurely assuming malfunction rates will protect the boat. Evade aggressively and expect sustained attacks with high-functioning weapons. By April 1944, 5 months after Jack Morrison had installed his first copper washer modification, the Allied anti-submarine forces in the Atlantic had sunk 47 German U-boats using depth charges as the primary weapon. 47 submarines, each crewed by 40 to 50 men, destroyed by weapons that had previously been regarded as marginally effective area denial tools. The casualty figures told the story with brutal clarity. In those 47 submarines, approximately 2,115 German submariners died, but those deaths prevented far greater losses on the Allied side. Naval intelligence analysts, working with convoy routing data and historical U-boat attack patterns, calculated that the 47 destroyed submarines would have sunk an estimated 94 merchant ships totaling 620,000 tons if they had remained operational through April 1944. Those merchant ships carried crews averaging 45 men per vessel. The Morrison modification had therefore prevented the deaths of approximately 4,230 Allied merchant seamen, not counting the hundreds or thousands of soldiers and civilians who would have died if those ships, carrying war materials and supplies, had been sunk. The cost-benefit analysis was staggering. The U.S. Navy spent approximately $14,100 to equip every destroyer escort in the Atlantic Fleet with enough copper washers to modify their depth-charge loadouts. That investment of $14,100 resulted in 47 submarine kills valued at approximately $235 million in replacement costs, not counting the trained crews that Germany could not replace. Jack Morrison, the 22-year-old welder, who had started this chain reaction with a hardware store copper washer, was promoted to Torpedoman's mate second class on January 15, 1944. He received the Navy and Marine Corps Medal on February 20th for heroism not involving actual conflict with an armed enemy. The citation specifically noted his initiative and technical innovation that directly contributed to the destruction of enemy submarines and the preservation of Allied lives. But the greatest honor came on March 3, 1944, when Admiral Royal Ingersoll, Commander-in-Chief of the Atlantic Fleet, visited USS Buckley during a port call in Boston. Ingersoll, who rarely left his headquarters for ship visits, personally presented Jack with a letter of commendation that included a paragraph that would be framed and displayed in the Navy's Explosive Ordnance Disposal School Museum. Torpedoman's mate Morrison's field modification of depth-charge detonators represents the finest tradition of American technical innovation and practical problem-solving. Using materials costing less than $1, he solved a problem that had plagued the Navy for years and created a solution that has proven decisive in the Battle of the Atlantic. The Morrison modification remained in use throughout World War II and into the early Cold War period. The final official implementation came in 1946 when the Navy's Bureau of Ordnance incorporated the copper washer seal into the standard specification for all new depth-charge detonators. What had started as a field expedient modification became permanent Navy doctrine, a testament to a young welder who had paid attention to why weapons failed and figured out how to fix them. Jack Morrison left active service in November 1945, returning to Pittsburgh with 3 years of naval experience and a skill set that made him extremely valuable to shipyards reconstructing their operations for peacetime production. He never spoke publicly about the depth charge modification, never sought recognition beyond what the Navy had already given him, and never claimed to be anything more than a sailor who'd gotten lucky with a copper washer at the right moment. But the numbers told a different story. 47 German U-boats sunk. Approximately 2,915 enemy submariners killed, an estimated 4,230 Allied merchant sailors whose lives were saved because submarines that would have torpedoed their ships were instead destroyed by depth charges that actually worked. And all of it traceable back to November 9, 1943, when a 22-year-old torpedoman noticed that saltwater corroded detonator seals and realized that a 47-cent copper washer could solve the problem. The Battle of the Atlantic turned on many factors: Allied code breaking that revealed U-boat positions, long-range aircraft that closed the mid-Atlantic air gap, improved sonar and radar that made submarines easier to detect. But among all those technological and tactical advantages, few were as simple, as cheap, or as immediately effective as Jack Morrison's copper washer modification. In the Anti-Submarine Warfare Museum at the Naval Station Norfolk, there's a display case containing one of the original modified depth-charge detonators from USS Buckley. The copper washer is still in place, green with verdigris after 80 years, but still performing the function for which it was installed. The placard beside the display reads, "Morrison Modification, Copper Washer Depth Charge Detonator Seal. Cost, 0.47s. German U-boats. Sunk, 47. Allied sailors saved, 4,200 plus." Sometimes the smallest innovations have the largest impact. The German submarine veterans who survived the war and later visited that museum often stopped at that display, studying the simple copper washer that had helped destroy their comrades and their cause. Hans Meckel, former commander of U-847, sunk by depth charges on August 27, 1943, before the Morrison modification became widespread, returned to the museum in 1973 and spent 20 minutes examining the detonator. His comment, recorded by a museum docent, summarized the modification's impact from the German perspective. "We knew American depth charges were unreliable. We counted on it. When they started working properly, when every charge in a pattern exploded exactly where it was supposed to, we lost our main defensive advantage, a simple washer. We were defeated by a washer that cost less than a pack of cigarettes." The technical legacy of the Morrison modification extended far beyond World War II. Modern depth charges, smart mines, and anti-submarine weapons all incorporate multiple redundant sealing systems inspired by Jack Morrison's simple copper washer solution. The principle of creating secondary mechanical seals to protect critical electronic components in marine environments became standard practice in naval ordnance design. But perhaps the most important legacy was the lesson that innovation in warfare doesn't always come from laboratories, design bureaus, or engineering schools. Sometimes it comes from a 22-year-old sailor, standing on a pitching deck in the middle of the Atlantic, holding a coffee can full of hardware, and paying attention to why things fail. Jack Morrison died in 1987 at age 66, having spent 42 years after the war working as a master welder in Pittsburgh shipyards. His obituary in the Pittsburgh Post-Gazette mentioned his Navy service in a single sentence and made no reference to the depth charge modification that had changed anti-submarine warfare. But at his funeral, attended by 14 former shipmates from USS Buckley and a representative from the Secretary of the Navy's office, the chaplain read from a letter that Admiral Chester Nimitz had written to Morrison in 1945. "The character of American fighting men is demonstrated not only by their courage in combat, but by their ability to solve problems with whatever materials are at hand. Your copper washer modification exemplifies this spirit and has saved thousands of lives. The Navy is in your debt." The final accounting of the Morrison modification's impact came from German naval records declassified in 1968. Gross Admiral Karl Donitz's personal papers included a strategic assessment dated May 15, 1944, that identified the sudden increase in depth charge reliability as one of 3 factors that made continued U-boat operations mathematically unsustainable. The other 2 factors were improved Allied radar and the closure of the Mid-Atlantic air gap. The Morrison modification stood alongside technological advances that had cost millions of dollars and required years of research. And it had started with a copper washer that cost 47 cents. The Battle of the Atlantic officially ended on May 8, 1945, with Germany's unconditional surrender. In the final accounting, German U-boats sank 2,603 Allied merchant ships, totaling 13.5 million tons of shipping. The Allies destroyed 783 U-boats, killing approximately 28,000 German submariners. The Morrison modification, implemented in November 1943, accounted for 47 of those U-boat kills directly and contributed to the destruction of an estimated 150 additional submarines through improved depth charge effectiveness in combined operations. The copper washer that Jack Morrison installed on that cold November morning in 1943 became one of the most cost-effective weapons modifications in military history. It required no new technology, no advanced materials, no complex manufacturing processes, just a simple mechanical seal that prevented saltwater from destroying detonators, installed by sailors who understood that in war, the difference between success and failure often comes down to paying attention to details that everyone else had overlooked. In the end, the story of Jack Morrison and his 47-cent copper washer wasn't really about innovation or engineering or even anti-submarine warfare. It was about a young man who refused to accept that weapons failing 70% of the time was normal, who took responsibility for fixing a problem that wasn't officially his to solve, and who created a solution so simple and effective that it saved thousands of lives and helped win the Battle of the Atlantic. 47 U-boats. 4,200 Allied sailors whose lives were saved. All because someone noticed that salt water corroded rubber seals and realized that copper washers could prevent it. The simplest solutions are often the most profound, and sometimes 0.47 is worth more than all the gold in the Atlantic.